All right, in today's video, we're going to do a little bit of review, and then I'm going to work a couple of problems on your homework tonight to make sure that you get started and are doing fine. Here's our first example, and I have a screenshot of a Desmos problem. All right, first off, if we asked, does this open up or open down, what they want you to do is be able to look right here at your A value. If your A value is positive, it's going to open up or give us what looks like a U. So if it's positive, it opens up. If it's negative, it's going to open down and look like an hill or an upside down U. So this one is going to open up because our A value is positive. The next thing, the x-intercepts. Well, this one has two x-intercepts right here at -5 and also at +1. So I can write that as -5, and I like to use a little and symbol here, 1, or you could write it as the points -5, 0, and 1, 0. Either way of writing your answer is fine with me. The y-intercept. All right, this one has one y-intercept, and it is this point right here. It crosses the y-axis at -10. So again, you can write your answer as -10, or you can write it as the point 0, -10. Either way of writing your answer is fine with me. All right, the domain. Now, up here, this line continues up and to the left, and over here to the right, it continues up and to the right. Now, up and left is still left, and up and right is still right. So the domain, if I ask how far left does it go and how far right does it go, it goes on forever and ever in both directions, and it actually covers every single number between left and right. So it is all real numbers, and you may remember that from a while back. All right, now the range. The range is how much does it go up and down. Well, again, both these arrows right here says it goes up forever and ever, but at what point does it stop going down? And I can look at the vertex right here, and it says that it goes down to -18, and if I come over, I can see -18 right here also. And it's always above -18. So I need to write that on the y-axis, it's always above, it's always bigger or greater than. It actually hits right at -18. So I put the or equal to. All right. Is it increasing, or when is it increasing? Now this again is our roller coaster problem. The increasing and decreasing is the roller coaster. So imagine a roller coaster who starts on the left, looks like he's going down the hill until right here at -2, and then he's going back up the hill. So when is our roller coaster increasing or going up the hill? Well, we would say from -2, right here, and it goes up forever and ever and ever and ever and ever. So I'm going to have to call this positive infinity because that's going to the right, and that's where the positive numbers are. So I'm going to say from -2 on the x-axis to positive infinity. Now, when is our roller coaster decreasing? Now, if positive infinity is to the right, negative infinity is on the left. So it keeps going up and left, which is still left. So up and left is negative infinity, and it's going down, 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 down until it gets to -2. So our roller coaster is decreasing from negative infinity on the x-axis to -2. Now our vertex, this is the highest point or the lowest point. In this case, it is the lowest point, otherwise known as the minimum. So our vertex is -2, -18. Is it a maximum or minimum? And again, this is the lowest point, so this would be a minimum amount. And the axis of symmetry is the imaginary line that goes through the vertex, straight up and down, it splits it in half. So our axis of symmetry would be this line right here. And the equation would be x equals -2. And we know it's -2 because of that number. And because if I continued my line, it would cross right here at -2. So the axis of symmetry is x equals -2. All right, our second example, again, does it open up or open down? So we can look right here, and since that's negative, I know it's going to open down. But if I come over here to the example and I look at it, it obviously opens down. It gives us me like a giant U. So this parabola opens down. All right, the x-intercepts, it looks like there's two of them on this one. Right here at 0.564 and 4.436. So I'm going to write both of those. And 0.564 And I like to use a little and symbol here. 4.436. The y-intercept, it looks like it crosses right here at -5 on the y-axis. So the y-intercept is -5. The domain, again, does it ever stop going left or right? And the answer is no. And it covers all the numbers in between the left and the right. So this is all real numbers. The range, does it ever stop going up or down? Well, again, it never stops going down and left, never stops going down and right. So it's always going down on both of these. But at what point does it stop going up? And it stops going up right here, which looks to be about 7.5. And we can look right here and get the exact number, which is 7.5. So it's at 7.5, it hits 7.5, and it's always below it. So on the y-axis, it's always below, less than, and it actually hits right at 7.5, so I'll put an or equal to. And that's my range. Now, increasing, where is our roller coaster going up? So if I start on the leftmost part down here, and again, I put my arrow there, this left and down is still left. So this is going left forever and ever and ever. So that's -infinity. And my roller coaster is going up from -infinity all the way to 2.5. So that's when my roller coaster is increasing or going up. So from -infinity all the way to 2.5. And when is my roller coaster decreasing or going down? Well, right here is where it starts going down. So at 2.5, and it's going down all the way to over here, which is the positive infinity because it keeps going on forever. So from 2.5 to positive infinity. All right, again, my vertex, this is the highest point or the lowest point. In this case, since it's the highest point, it is called a maximum. And my vertex is 2.5, 7.5. And again, like we just said, it's the highest point, so it's a maximum. The axis of symmetry is the imaginary line that goes right through the vertex and splits the sucker right in half. The equation is x equals 2.5, and we know that because in the vertex, our x value is 2.5. And if I look down here, it crosses at 2.5. So x equals 2.5 is my axis of symmetry. All right, this is going to be your homework for tonight. Now, I wanted to work a couple of these problems to make sure that you understood what you needed to do. And if you had any questions, hopefully this would eliminate them. All right, I'm going to do number 1 right here. So I'm going to zoom in on number 1. A builder is designing a rectangular parking lot. He has 400 feet of fencing to enclose the parking lot around the 3 sides. Let x equal the width of the park. And let a equal the area of the park in the function a of x equals -2x squared plus 400x. Now again, a is the area, but when I type it in, I'm going to say y equals instead of a sub x equals. Represents the area of the parking lot as a function of the width. Now I went ahead and graphed this on Desmos over here. And the directions up here say to use technology to determine the absolute maximum of each function. Describe what the x and y coordinates of this point represent in terms of this problem. So let's go over here and find the vertex. And again, I used a screenshot of Desmos. I would type it in, and that I expect you guys to do that also. And I see that the vertex is the point right here. It's a maximum. It's at the highest point, 100, 20,000. So if I go back over here, I'm going to write my answer. The vertex is 120,000. And I need to write what the x stands for. And if I look up here, it says x is the width of the parking lot. So I know that x equals 100. Well, that's going to be the x equals 100. But that is the width of parking lot. And the y, or the a, is the area of the parking lot. So the y is 20,000, which represents the maximum area. And that's how you do these first 6 problems. All right, the next section, write a function that represents the vertical motion described in this problem situation. I have my vertical motion equation at the top. And again, -16 represents gravity pulling our object back down to the ground. T stands for time. V stands for the upward velocity, or how hard that thing is shot up into the air, and H is the starting height. And again, like for instance, a golf ball or a soccer ball would start on the ground at 0 feet, but a football would start at about shoulder height when you release it. So the starting height is going to be different depending on the problem. So I'm going to work number 1 here for you. A catapult hurls a watermelon from a height of 36 feet at an initial velocity of 82 feet per second. So to write my equation, I'm going to say y equals negative 16 t squared. And again, the only numbers I need to plug in for are the velocity and the height. So plus, and my velocity, it says 82 feet per second. So plus 82 times time. And my starting height from this catapult is 36. And I'm done. You only had to plug in 2 numbers. All right, the last section, identify the vertex of the equation and the axis of symmetry for each vertical motion model. All right, I think I have a screenshot of number 1 over here, but it says again, a catapult hurls a grapefruit from a height of 24 feet at initial velocity of 80 feet per second. It gives us this equation right here. So I need the vertex and the axis of symmetry. So what I would do is I would graph that on Desmos, and I got an example of it right here. And again, my vertex is 2.5, 124. So I'm going to go back and write that down. Vertex is 2.5, 124. And now I need my axis of symmetry equation, and you have to write x equals. If you don't write x equals, it's going to be wrong. So x equals, and it's always whatever number this is right here, and my x value is 2.5. So my equation for the axis of symmetry is x equals 2.5. And that's how you do this final section. All right, good luck on your homework, guys.